continue where we have stopped last week. So I was explaining on how to create our own tool step by step on medical report analysis. Our main topic was radiology, but in this case, we can analyze all the reports, including radiology reports, clinical history of a patient, and also lab results and whatever the clinical notes we are having. So for that, I was explaining a solution using a large language model. It might be ChatGPT or some other large language model like Llama, Mistral, or some other model. So today I am going to explain how you can do it in practically, how you can get it done by yourself. But I don't go into detail level of the coding, but I'll show you that we can do it without using the ChatGPT or the large language models to analyze our reports. We can use their APIs or freely available open source models to get this task done. So this was the use case that we were discussing last week. That is the same use case. So we are going to analyze radiology reports with other patient data available. So the purpose is to get important insights on those data and also summaries or whatever the by giving your own prompts, you can get whatever the details you want by analyzing those reports. Okay, one of the most important thing in that case is patient privacy of patient data. So let's discuss how we are going to handle that. Okay, before moving to that one, let me quickly explain what is ChatGPT. The ChatGPT is a large language model. I put this comparison here because there are some other models also like ChatGPT. Most people use ChatGPT and ChatGPT API when they are developing applications because it is highly capable in this case. So with ChatGPT, we can see there are a lot of other large language models as well. You might have heard and you might have used these tools like Claude, Gemini from Google, and DeepSeek. And these last two are open source models that we can use freely. Llama is not for commercial use, but Mistral you can use. And DeepSeek also you can download and you can use locally. But ChatGPT you can't do that because you can't download ChatGPT and use it locally. So still there is a problem when you are using ChatGPT to provide solutions because there is a privacy issue. So we will discuss about that. Okay, ChatGPT, if you are using ChatGPT, you know that there are three versions. So one is the one you are using, most of you are using the free version, I think. So it is based on GPT 3.5. That is less capable than GPT-4 Turbo model. So the Turbo model is used in Plus version. That is $20 per month. And the speed is also faster in Plus. reasoning ability is better in Plus version than the free version. And the tokens. 16,000 tokens are available in free version, and plus there are 128,000. That means you see a limitation in free version. If you're most of the time, if you work with ChatGPT, you might have noticed that sometimes you exceed the limit of using it. So uh, availability also, the priority access is given in plus version. So this is about ChatGPT. I'll explain about ChatGPT API as well. Before moving to that, I'll quickly show you. Wait, I have my slide. Okay. Yeah, pricing here, if you go to openai.com, you will see the pricing. So what is OpenAI? So there is image generation tool provided by OpenAI, and this ChatGPT is OpenAI. Likewise, there are a lot of other products uh, available. Products are provided by OpenAI. Then OpenAI is the company. So ChatGPT is the product. So here is the pricing model. You can see more details later. What are the differences of each version? Why GPT-4 Turbo is better in medical use. I have included this slide also. If you are using free version, I recommend it's better if you can go for the plus version because of these limitations. Token means it's around, if you have 1,000 tokens, that means around 750 words you can use. Like that, there is a meaning for these tokens. So that is, I mentioned that related to ChatGPT API that I have used. I'll show it to you later. So anyway, it is better to read these informations. So accuracy also I found low. It is lower in free version than the paid versions. Yeah, if you are handling medical queries, then sometimes you cannot rely on the answer always, the answer that you are getting from the free version. Okay, this is our prototype. I'm going to create a prototype for the problem that we have discussed already. So that is to analyze the patient medical reports. So for that, I use a tool called LangChain and ChatGPT API. So there is a difference between ChatGPT and ChatGPT API. So I think most of you know what is an API. API is an application programming interface. So developers most of the time work with APIs because APIs are available for developers because they are using APIs to build their applications. So if you ChatGPT is, you are using ChatGPT because you have nice front end in that application. So you can use all the functionalities of ChatGPT using that interface. But for an API, you don't have an interface like that. So you have to use the methods provided by API and build your own system. So you can think of it as a messenger between two software systems. For example, like in your hospital, if you have a hospital system, then in that hospital system, you might not have a appointment planning system, for example. So you are using the hospital system, but for the appointment planning system, you are using some other system, not module in the same system, but some other system. So in that case, you can use in the system you are using in the hospital, maybe that system is accessing the API of the appointment planning system and provide you certain information to your system in order to get all the information, all the appointment information about a particular patient. So by giving the patient ID, you can get all those information. Like that, um, so if there is an API, we can call the API and get the data of that particular application, or call the method, or in other words, you can use the functionalities in that system. So in ChatGPT also same. I remember someone asked that question. That's why I explained it a little bit. If some people are not aware about API, then ChatGPT API is something else that is uh, not the ChatGPT you are working with. I'm talking about the API. So you can use that API and create your own tool. So here I have mentioned the steps, not the steps actually. This tool will accept patient data. We can upload our reports. We have like radiology reports, lab reports, or whatever the reports you have related to a particular patient. And then extract medical insights and summarize them. You can get it summarized. So here we use LangChain. LangChain is also a tool provided for developers. I'll explain it later. So we will use LangChain to we are using these prompts, right? We are working with these prompts, and also with those tools, the data provided by API. So we have to work with API. So in order to do that orchestration, we can use this LangChain tool. So it is very easier if you are using this tool in order to get this done. So and we will use ChatGPT API to generate the output. Yeah, and also we want to process data locally. So we'll show you whether to which extent we can do it. So language, as I told you, LangChain is a open source framework. So that is something good. So we can freely use it to work with large language models like ChatGPT. We can use that tool. Yeah, LangChain is used for chat to generate chatbots like this and AI agents. So in future session, I'll explain you about AI agents. So those are very popular these days, and you can get a lot of things done by AI agents. We'll discuss that later. So for the apps that query documents, PDFs, any other file formats, so these we can create apps to analyze those documents using the functionality provided by LangChain, and also workflow systems. Workflow systems are not like the systems that we are working. There are multiple steps. When we want to get something done with multiple steps, then we can implement those kind of solutions. And knowledge base and question and answer systems also. In this application, we use something called Streamlit also. Streamlit is that is again open source Python framework, and we can easily build interactive web applications. So those days, it was very difficult to create web UI because we have to do everything manually. But here it is very easy. We can quickly create such web UI web applications using Streamlit. So specifically Streamlit used in AI context, that is because it is a Python framework. Okay, for this task, we have to set up the environment first of all. So for this, we have to get a ChatGPT API key from OpenAI website. So I'll show how you can do it. I'll use another browser because I can't show the steps in the other one since I have already created. Okay, this is the URL platform openai.com. Here if you click on settings, you will see the API keys. I am not going to do this with you because today we won't be able to do that. Before doing this exercise, you need to know a little bit of Python. So then you can try this out. But I'll include everything in the slides. So you can go to these websites and check these things because it is important to know these things. Okay, here in the settings, you will see API keys. So from OpenAI website, you have to create a new secret key. For this, you have to give, before coming to this screen, there is a registration process, like you have to give some of your personal details. So after that, you can come here and you have to give the, you might have to create a login as well. Okay, here you have to give a name and create secret key. Okay, in here, I created the key quickly because I already logged into this site. Otherwise, when you are creating for first time, you have to make a payment as well. So in order to get a key, I paid $5. But it is worth doing that. Then only you will be able to try out all these examples. So you can try it out. So in my case, when I pay $5, I could get 125,000 tokens. So it is more than enough for me to work with it for a long time. So I'm also trying out different applications like that. So if you calculated it for a full page of text, it will take around 500 tokens. So you will do the calculation because all the details are available in these websites, and also you can get the support from ChatGPT to see how it works. So when you pay that amount, how much you can use. So otherwise it's not worth. But I am telling you that since I have tried it out, if you pay that amount and if you try these examples, then you will learn a lot of things. Okay, then you have to install Python. I have shared the website to download Python, so you can get it downloaded. Last week I have shared some of the examples as well. And also from the ChatGPT, you can get the support in creating some sample examples. Okay, after that, you have to install these Python packages. That is LangChain, OpenAI, and Streamlit. Because as I explained you, I'll use the framework LangChain in order to connect all these tools, APIs, and get this thing done. And OpenAI is will be used as that is the ChatGPT API that I am going to use. So when you are using a API like that in your application, you will call the methods provided by API, that API. So in order to do that, you should have this package as well. And Streamlit will do a nice job by giving you a beautiful interface for your app that you are going to create. Okay. Then you are going to create a simple interface using Streamlit, where you can upload your patient files, and then it will extract the content of those files and we'll send it to OpenAI and get the output. So the processing part will happen in the server. That's why I told you still there is a privacy issue. Okay, because here as a output I have mentioned too, if you are using local LLM, like I told you, I have shown you in the previous slide, it can be a Llama model, Mistral, or maybe DeepSeek. Like that, you can use some local large language model as well. We'll do that exercise also in maybe next week session. Okay. Okay, before going to this slide, let me show you the app that I have created. Okay. I told you that you have to install Python. You have to install Python and also those Python libraries, LangChain. But here I can't show it to you. I have already installed those libraries here because I have created the environment, and also I took the API key already. Otherwise it takes time. So I have saved it here in .env file. That is the way how we are doing it. We are saving that file in, that API key somewhere, and we will use that API key in our code. So we should have that API key in order to connect to ChatGPT API and call its methods. Here, this run will be executed because I have this API key. Otherwise, it will not be executed. Probably other lines might get executed. Okay. Before showing this code, I will show you the no. First of all, let me explain you what is this. This is Visual VS Code. So this is the tool that I am using for my coding. So for Python, if you want to write Python programs, also you can use this Visual Studio Code. But there are some other editors as well, but this is easier for me. So what I did was I installed Python, and then in this editor, I started writing the code. So when writing the code also, I didn't spend much time because I know what I am doing and I know the code logic. So because of that, for my convenience, some of the parts I took from ChatGPT as well. Okay. Let me show you. I think it's running. No, it's not there. Here, we have a terminal. So we can get a terminal and execute our Python code. Actually, for this task, we have to create an environment as well. That is just issuing a code. It's not a big thing. So I have created that environment. So I'll connect to that, activate that virtual environment. And then I am in this folder in Dev AI Report Analyzer example 2. I have a folder like example 2. In this folder, I have created this py is the extension for the Python files. So I have created some example files. So the first one is app py. I have created that one and I'll show it to you. This is how you have to run it. So Streamlit, I told you that is the one we use for GUI to provide a nice UI. So we will execute the run command and then I'll execute my Python application. I'm just showing this code to um, code because I want you to know that it's not that difficult task. So you also can learn and do these type of things by spending a little time. Right. This is the application. So this is the entire code. It's not a big thing. This is the entire code. Okay. Here I can first of all, I'll demonstrate it to you. Later, I'll explain what I have done in the code. Okay, I wanted to specifically create this one. Now you have to understand that this is not ChatGPT UI. This is the UI that I have created, but ChatGPT also connect into the ChatGPT backend. So I'm also connecting to the same model by using their API. Okay, this UI is created using Streamlit. Okay, I'll upload some of the files that I have created already related to the patient name is John Doe, and I have created a sample radiology PDF. Let me quickly show what are those files to you. This radiology sample that I got this also done from ChatGPT. I don't know much about the context, but I think you will be able to understand it. And also, I have both versions, PDF and Word format. But I created that in order to show that we can use all these file formats. PDF text files or Word files, whatever. So there is a file which includes clinical notes as well. It contains some history, medical history, like this. This is also a dummy content. Okay. Okay, here one problem is all the patient name, age, and the details are included. Okay, this is a lab report. Right. I'm going to upload all these reports to, I already uploaded radiology report. I made this information visible for you. Then you can understand what is happening. Otherwise, normally, if we are creating it proper, because this is just a prototype, if you are creating a tool correctly, then this is not the way. Lab and clinical notes also uploaded. Now 3 reports are uploaded to the tool. Okay, it extracted the content from the file and shown these files here. So you can now give a prompt and find some useful information. I created some few of the sample prompts as well. Okay, it gave me an answer like that. But the question I asked was, what differential diagnosis should be considered based on these images? Yeah, it gave something like that. And also I can ask, how can I explain these imaging results to the patient in simple terms? Something like that. You can explain to the patient that the imaging results show some blockages in the blood vessels that supply the heart with oxygen-rich blood. Mild blockage in one artery and a moderate blockage in another artery, something like that. Okay, this is the first tool that I have created. So it is very simple, and I have a few other modified sample codes as well. I'll execute it and show it to you. Before that, let me explain a little bit about this code, because this is the most simple piece of code that I have right now. Okay, here I'm not going to explain about Python. We have to import all the libraries and stuff in order to write this code. That's why all the imports are going on top. But I'll quickly explain what is happening in the code. Load API key. So first of all, we should have the API key. And then this is the model. Chat OpenAI. This LLM OpenAI API key is taken and assigned to this one. And this will initialize the model that we are going to use. You can see LLM here. And then conversation. This is the initialization of the conversation. So we will initialize the large language model and the memory, and these parameters will be initialized first of all. And then this part is related to Streamlit application. So we have put a proper page title, radiology chatbot, and the title is Radiology Clinical Report Chatbot. This one. And like that, we will do the necessary coding for the user interface, the interface that we are looking at. So that part will be done using Streamlit. ST is the Streamlit. ST means Streamlit, that is the library. See, import Streamlit as ST. That means that is the Streamlit lib. So we are using. So I'm just explaining these things just to get an idea that it is not difficult. It's like it's more similar to human language. Okay, then upload patient report, upload files. So upload files, PDF, docx and txt. Those are also this part, upload files. That is also a text. That is a label that we are printing in the screen. So those are not that important. Those are very easy stuff. Okay, here there is a function to extract text. So when we upload those files through file uploader, once uploaded, we have to extract the content from those files. So in here, it happens, right? If it is a text file, we will do it like this and extract the text from the text file. And if it is a PDF file, it will be, the PDF file will be opened and extract the text, but use this fits that also defined here, import. Okay, like that, all the documents, the text from the documents is extracted, and then the patient context is built. So all the files, now all the extracted text will be merged and created that content and will make the content ready in order to send it to ChatGPT server, I mean the cloud servers, and get the output. So for that, we will use this patient context variable. So here we can see all the processing part is happening here. And we have the content locally until we send it to server. So this processed file content will be sent to server only when you click on the analyze. In here, there is no analyze button. For the next example, I have put analyze button. But in this case, the user input, this patient content will be sent when you click on, when you put the prompt here and enter. So that is the time you are sending this content to the server. Then the server will process the content and will send the output. Okay, then this here is the line we call the ChatGPT API and send it to the server, and then we will get a response from the server. The response will be assigned to the variable, and then response will be written to your Streamlit here as an output. This is very simple, and that is how it is happening. So, okay. And I think you might have understand something from this code, but I just wanted to tell you not to teach you this Python, but I just wanted you to understand that it is not difficult. So, right, that is my first example. In the second one, let me quickly run the second example as well. This is the second one. Yeah, the difference is I have put an additional button to analyze these uploaded content. Okay. Yeah. Here also it's the same example I have modified a bit just by putting a button here that I wanted to put that button because in order to show you that this is not like if you work with ChatGPT, you have only limited functionalities like you what are the available features you can use. But if you are creating your own application like this, then you can put what you can modify it as you want. If you don't want to analyze, write queries, prompts like that always, then you can certain things you can keep pre-built and click on this like this. Click on the analyze patient reports. Then you can get the analysis like this. Okay, for that I made only a small change in the code. Analyze button. If analyze button is clicked, this thing will be happen again. If you click analyze button, it will talk to the API conversation.run by sending the input. Okay, and the third example here, I think I don't have to run the example, but I can explain it in the code. Here, what I have done is I have anonymized patient details. As I shown you in the PDF files, the patient name, age, and all the personal details were there. So we can anonymize the data like this. Here we have anonymized patient ID and date of birth, name. Yeah, the most critical information we can hide like that when sending the data to the server. Because we know now the processing part will happen in cloud, the servers, but not locally because we are using that model. That model is available in the server, not locally. So that is the problem we are having. Even though ChatGPT is highly capable, we have that privacy concern, and we can use certain techniques like this by anonymizing data, masking data, kind of things. But it's not a proper solution uh, because anyway we are sending the data to the server. Let me quickly run F3 as well. Because I cannot show that functionality to you because it is not here. It's happening when you are sending data to the server. So I have put this privacy note. Your reports are automatically anonymized before analysis to protect patient confidentiality. So we can't see it, but it's happening in the code. We have written the code like that. Okay, in this chatbot, I'll issue another query. Sorry, I have forgotten to upload the reports. Okay, I told correlate the patient symptoms with the findings in the CT angiogram. Um, something. I got the output like this. Like that, we can, the same way we are working with ChatGPT, we can write a tool like this and give our prompts and use it. And we have the more flexibility to customize as we want. But that privacy issue is there. Okay. Yeah. Let me go back to the slides. Here I have mentioned where are uploaded report process. That is something important that you should know. You send the report content in a request. So this is, I have shown you this run command. So what happens? The text is sent over the HTTPS connection to OpenAI servers. So the request will be sent and processing will happen there. So OpenAI's model processes the text. So the processing will happen uh, in, in server side. The API respond with the reply using the content you send. The other important thing is by default, nothing is stored or saved permanently. Even though we send the content, it is not stored in the server. So I'll show you the privacy statement in OpenAI. We are committed to privacy and security for our ChatGPT business products and API platform. So here it is mentioned, you own and control your data. We do not train our models on your business data by default. You own your inputs and outputs like that. They don't use our data, or they don't save, they don't keep our data. They are not using those data to train their model, or nothing will happen like that. They will temporarily use uh, our data in order to give the output. And also in the tool I have shown you, within the session only those data is available. So it is not better to store data in locally as well, patient data, um, because it can be accessible by others. So for that, we have to carefully um, write our codes and select our tools when we are implementing this type of solution, especially in a domain like healthcare. Okay, let me go back to my slide. Okay, by default, nothing is stored or saved. Your content is not used to train, and enterprise users or privacy conscious configurations. OpenAI guarantees no logging or storage. They guarantee that they are not doing anything, but still we are sending the data to the outside, to a cloud. So there is a concern. Okay, that's all in my slides. Here I have mentioned the website of LangChain also. So you have access to all these details. If I find additional materials, I'll send. And if you have any question related to the example that I have done today, you can ask. Next day, I'll try my best to show you something, try to implement something in more secure way than this, and like using a local deployment. But for the moment, if you have, because this is the most simple way that you can do it. So if you have any question, ask from me. Okay. And I want to show you something. I think you know already about DeepSeek, because I am going to show it to you next week. Here, this one, deepseek.com. So you have to register for this also. You have to authenticate. And now, since I have used this many times, I can quickly log in. For this also, I will add my report. I'll use this prompt. How can I explain this imaging results to patient in simple terms that might be relevant to radiology based on. So I have selected this deep think. That's why it is thinking deeply and giving me a proper analysis, and very good output, which explain everything in detail. So this DeepSeek is also a highly very advanced model that we can use even in locally we can deploy. So I want you to go to DeepSeek, and the same way you are using ChatGPT, you can give your prompts and see the results, and then you will be able to see a difference. So I'm not telling that this is better than ChatGPT, but sometimes we better to use couple of tools and find the best answer for us. So see how it is analyzing my question and giving the reports that I have given, and give an answer like this. Yeah, you might understand these things better than me, and then you are the one, you will be able to realize what uh, the tool is best for your problems. So try all those things. And there is this web search option as well, and deep think option as well. You can give a file, you can attach a file only when you select. Yeah, for the web search you can't, but for the deep think you can. There are like many differences in these tools. You can see the differences also by using by issuing a prompt to one of these tools. Yeah, so do these experiments. Okay, and I'll show one other input. Sorry. I have this version. ChatGPT 4 plus version in ChatGPT plus. I want to show you something special. Sorry, I can't get it now. I processed the same by giving radiology PDF. I gave the same prompt in ChatGPT plus version. So it gave me a very advanced result than all the other tools. So with some images, or including some images also, when I use this reasoning model, its reasoning model, I think that reasoning model is not available in the ChatGPT version that we are using. I'm using the free version. So the other one I wanted to show you, that is one of my friends login. I am logging to that version, paid version. So it gave me a very good output for the same prompt. So if possible, you can try out, you can go for that version at least for 1 month and see the difference if you are using ChatGPT always. Okay, that's all in my slides. Before Sulo continues, if you have any question, you can ask. Is it interesting, or should I change the way or the content that we are doing? Do you think that you find anything useful in today's session? Or let me know whether you want to learn more about it. Then we can include some Python session as well. Then later on, you will be able to do this type of coding stuff and try out these things. I can send you the code that I have written today. I mean, I can put it somewhere and share with you, like in GitHub.
That would be
Silosha, I think you can continue.
Yeah, thanks, Mahesha. So, hi everyone, good evening. Let me first share my screen. Okay. So, can everyone see my screen?
Yes.
yes.
We can.
So, okay, wonderful. Okay, so okay, so I'm asking everyone to get engaged with this next 1 hour, because I am going to discuss some of important and core concept of AI, right? So why I'm asking you guys to engage or listen this slide or listen this lecture very carefully is that I am going to explain a couple of the important thing and thing to understand the core idea of the machine learning and some AI stuff, right? So before I start my lecture, I wanted to connect my lecture with the thing what Mahesha explained to you guys, right? Okay, so here, so Mahesha explained this thing. If you did not understand some stuff from Mahesha lecture, just look at this screen so that you can get the better understanding about that part as well as the part what I'm going to explain, right? Okay. So Mahesh explained it that we have, let's think about, here we have LLM model, let's say called ChatGPT, whatever the model, right? ChatGPT. Let's get everyone of the ChatGPT, no? So ChatGPT, right? Here the ChatGPT, right? Okay. So this is a model or the service which already built by someone else, right? So what Maisha explained in her lecture is that how this train model integrate to a UI or maybe the interface to end users to get interact with, right? So you already know that this model is already providing a UI which is the generalized UI. Anyone can go and chat and get the result, but also there is an option to they are providing one option to developers or the other people to get connected their GPT based on our based on our requirements, right? So to connect this model, we use connection. Maybe I'm using very simple terms because I'm not going to explain little bit. I explain in a broader manner, but I will use some word. Maybe those words are not appropriate when it's come to the IT side. But I'm just trying to give away in a very simple way, right? So let's call this as a connection as an API, right? So using this, the interface is connecting with the GPT, right? GPT model, so that you can, whatever the way you can customize this the how you are putting the prompt, and you can, when you're passing the prompt, you can in the middle of the, when you're passing, you can I mean embedded some prompt to the I mean to simplify the output. Likewise, there are a lot of ways, lot of things you can do if you are using the API in your own UI, right? But one thing you have to understand that however or whatever the way we are used uh, to implement this, it always use the GPT's existing knowledge, right? GPT's trained existing knowledge, right? So even though you use a UI, or even though you use the, what do you call, the paid version of this, but whatever the version you use, it is always used to train GPI, I mean the ChatGPT brain, right? Okay. So today I am going to show you one thing, that is, I am going to train one model, right? One model, independent model, by giving a data which we created already, right? So here we use the brain which is already trained, right? Now we are going to show you how we can start or create a fresh brain to get predict or get use our day-to-day works, right? Okay, so this is what we are going to do. So we are going to create this model. Then we are trying to get some try out whether the predicted values or predicted things are correct or not, right? This is not powerful as the GPT. You know that GPT is very powerful model. But the only thing what I wanted to say here is that this is trained for using lot of tokens or lot of keys and values, right? But here we are trying to train a model using very specific, using collecting the data from the specific area, right? Okay. So okay, let's move to the slides, right? Okay. So okay, so here Okay, so I have explained it here. Okay, so to create a model, to create a personalized model, we should have a problem. Obviously, we should have a problem. If we don't have a problem, we don't want to create a model. But this is my problem, right? Can we identify the key physiological and demographic factors that are predictive of type 2 diabetes in adults, right? This is my problem. So if you read this problem, the idea is that to understand and predict the risk level, or maybe the whether that person should be should we should give some treatment or not for the based on their physical and demographic factors, right? So this is my problem, right? So to solve this problem, I'm just trying to analyze, get a data set, or create a data set. Then I'm trying to analyze it. Then I'm going to create a model, right? That is today's session. That is what I'm going to do, right? Okay. So I will go slide by slide. Okay. So okay. So first thing, I am not a medical person. So I'm a kind of an production manager. I'm an engineer. So apologize me if I am spelling something incorrectly, or if I'm when I'm telling some medical related thing. So you guys, I know that you guys are better know about the medical field than me. So if I'm telling something wrong, please correct me then and there, so we can fix that thing and we can move with the rest of the part, right? Okay, so this is my general idea, right? This is my general idea. So when when we decide some type 2 diabetic levels, or maybe the person with the, in a usual term, is whether we categorizing in a general term whether this person is a diabetic person or not, right? That's the general term. So to categorize that, we usually use couple of factors, right? We when you ask some details from the first question, may be the age, right? Then the gender, then some cases you are checking the BMI, then you are checking some blood reports. You will get some data with some cholesterol, then TG, kind of the data you are collecting to get a understand whether that person is suffering from the type 2 diabetes or not, right? Okay. So here I have the data of 12 patients, right? 12 patients. Okay. So get this session very interactive. I am asking any of you, maybe a couple of you guys, can you just type in the chat box whether this is the patient number 1, 2, 3, 4, those are the patient number, whether those people are in a good condition, or whether those people need some diagnosis. Can you type, just looking at these numbers, can you just type in the chat whether which person should go to the need to get the medical treatment? Can you just look at these numbers and type? Let's get one, maybe 5 minutes. I will zoom this little bit. Anyone is trying that? Let me. Okay, so No one is yet typed. Do anyone want to give a try by looking at these numbers? Dr. Dumti, are you trying to say something?
I think P patient number P7, 8, 9, 10, 11, 12.
Okay. All those patients should
Yeah.
we should consider for a treatment, right?
P7, 8, 9, 10, 11, 12.
Okay, great. Yeah. Any other opinion? Like I'm not trying to like check the accuracy. Just wanted to understand from my understanding as well, right? Okay. Anyway, great. So thanks for that comment actually. 7, 8, 10, 12. Yeah, great. 7, yeah, 7 and 10. Okay. So okay. So based on this data sheet, so this is my my opinion. What I got from some other references, right? The 1, 2, 3, 4, 5. Maybe those 5 patients are kind of a good. They are medical. That based on this number, their medical status is kind of a good, right? But 7, 8, 9, 10, 11, 12. There are some based on the that based on these normal states, we should look at very carefully whether those people need the treatment or not, because the 7, 8, 9, 10, and 11, 12, those patients should have some issues in their the numbers uh, the numbers in the reports, right? Okay, so this is how I this is how I get an idea. So this is the usual range as I know and as I get from the internet. So what is the BMI? Then what is the usual cholesterol? Then what is the TG? Then what is the good cholesterol? Likewise, this is how I am pretty how I told you, like this the last set of patients should need to go to a treatment, right? Okay. So now I will show you one interesting data set, right? Okay. So as I showed previously, I have collected around 5,132 patients data to create this model, right? So for that, I got the data of all these patients. Like I get the collector, the patient age, then gender, then BMI, cholesterol level, then TG, then good cholesterol, bad cholesterol, then CR, BUN, and also based on the doctor's experience, I collected whether that patient should go with the diagnosis or not, right? The 0 indicate the patient is in a kind of a good condition, right? But I indicated as a 1, those patients should need some treatment to get kind of an indication those people are going to, or they are suffering from the diabetes, right? So I put the 1 for the patient, then I put a 0 for the rest of the person. So those things I got from some consulting some doctors. So this is their idea, right? This is their idea. Then these are the data, right? Okay. So this is the data set what I am going to use to train my model. So now I believe you already get an idea what I'm going to do. What I'm going to do is that I'm going to predict based on the data what I'm going to give. Like these are the 9 data what I am usually going to give to the model. Then model will automatically predict whether that person, that patient should suffering from diabetes, or that person should go with the diagnosis or not, right? Okay, so okay. Before I train the model from that data set, in the model training circle, we have to do couple of things before we do the model training, right? So mainly there are 8 steps, right? There are eight steps to be followed before we train a model, right? Before we train a model. Okay, so I know that so when I'm explain these steps, for some cases I will use the Python, but don't worry about that. I know that you are from the medical field, so you don't want to worry about the Python code, I think. But I'm asking you guys to get the core idea what I am doing, right? Okay, so first thing, step 1 is the data analysis part, right? So in the data analysis part, I will show you what is data analysis. If you are planning to train a model based on your data sheet, or based on the data what you have collected from your patients. So first you have to do a data analysis, right? This is very, very important before you start any model training process, right? Okay. So usually data science people doing this data analysis part probably they are using the Power BI, or we can use maybe the Python. Likewise, we can use different sites and different technologies to do the data analysis part. But to understand in a easy manner, I am using the Excel to show you some key component of data analysis part, right? Okay. So first, in the data analysis part, I am trying to understand the structure of the data, right? So in the structure, in the data set, I have collected around 1.8K data from the females. Then from the male, I collected 3.2K data, right? So when you look at this percentage, I have collected more people. So I mean the more male people from for this data set, but when it's come to the female, I collected very less number, because that is a number we found, right? But if you look at, I'm not sure, I'm just predicting this, maybe when I collect this data, maybe in general, diabetics are more more familiar disease for the males, not for the female. Maybe correct me if I'm wrong. In usually the the diabetes disease is very I mean the males are male people are the people who are suffering from the diabetes than the female person. Maybe that is my prediction. So maybe that's maybe the reason why I got able to collect 1.8K from female and 3.2K from male, right? Okay. Okay. So likewise, I am just analyzing all this data to understand the structure of the data. This is very important thing, right? Why I'm telling this important? Let's see, in this case, you have the male data than the female data, right? So in this case, probably this is correct because of the reason what I said earlier. But for some trainings, let's say you are thinking that in the last time I remember I showed you a more simple model training to classify cat and dog, right? Cat and dog, right? Cat and dog. For that, I used 100 cat images and 100 dog images. The reason this is very half, okay, I mean, same ratio, same size, because I wanted to like, avoid the biasness of the model. But when it's come to this scenario, the model may be biased to this male side because the number of data in the male is very high when compared to the female, right? But in this, in the scenario, I mean, in this medical scenario, this biasness may be correct because the male people are suffering from diabetes than the female people. So this biasness may be correct for this scenario, but we always, if a data scientist is analyzing this data set, so always they are following the same ratios or the very near same ratios before they train the model to avoid the biasness. Okay, so the gender wise, this is fine. Let's think about this, fine, right? Then you can find out, check other fields as well, right? How what are the numbers in the BMI, right? This is how I analysis. I just analysis 0 to 18.5. How many records I have in the 0 to 18.5. Likewise, I have analysis all this data, right? All this data, right? And in the similar way, I have analysis all these stuff because I just wanted to understand what is my structure of the data. And I try to, let me show you, okay. And I try to draft some frequency table. If you remember your grade 11, maybe grade 11, 12, 11 or A-level statistic, I created some frequency table to understand how the distribution, how the data is distributing when we get the data set as a one bar, right? So this is how the age distribution we have. Then this is how the HDL distribution. Then this is good cholesterol. Likewise, I try to analysis because let's say, let's think about this, right? If in the age group, if you see, let me show, like, let's see. Okay, I will take this as a snapshot. So I'm just trying to tell you the importance of this data analysis part, right? Let's think about, so this is the age group distribution. Just think about, so I am just, I think as I remember, okay, I will take with the numbers here. Okay, so just think about, let's say, so if you see, I will draw this x-axis to till some extent. Let's say this is 19, then this is 100, maybe this is 120, and maybe 150. I mean, I'm getting the age, right? If you look at this data set like this manner, do you think that this data section, I have done this data section correctly? Answer is no. Why? Usually people are not living till maybe 150, 120, right? So those kind of errors you can detect only you are looking at this the distribution visually, right? But if you look at this just the numbers, if I go to this data sheet, you cannot find out those errors, right? So that's what I am telling, that this data analysis part and getting understanding of how the data distributed among the record is very, very, very important, right? Okay, so this is my step number 1, right? So now I know my data is, when I look at this data sheets, I am 99% confident that I collected this data, or I downloaded this data in a without I collected this data correctly, right? Okay, so then I am going to the next one, right? Data cleaning part. So here, so I will do, okay, so in the data cleaning part, right? In the data cleaning part, I am just trying to understand in a simple manner. I'm just trying to understand whether when you are check the visually, the data visually, you might see some, if you see a, if the data sheet has a big error, you can see in the visually, but if the data sheet has a very small errors, probably you cannot see the data in the data sheet, right? So in the data cleaning part, I will go the column wise, whether to understand whether it has some null values, or whether it's some outliers, or whether it has some incorrect entries, right? Okay, so first I'm starting with the age, right? This is I'm telling again, this is not the proper way to data cleaning, because we have to use Python and other libraries and other command, but to give the basic of the data cleaning, I'm doing the Excel to do the data cleaning process, right? Okay, so first I'm going to H, right? I'm just checking whether is there any null values, blank values, and whether the unpredicted values is here. So if you look at this data, look like good. You start with 20, then ending with 93 years. Then there are no any blank values. So look like the data gathered under A is good, right? Then I'm going to the gender. So in the gender, there are two categories, female and male. Then that sheet is also good, right? When it's come to the BMI, look like that is also good. The distributed from 15 to 42. Look like there are no any blank value or incorrect entries, probably. And okay, so if you look at this one, you might see some zero values here, right? I will show this one, right? So I'm just asking a question from the domain experts. You guys are the domain experts. I'm just asking, okay, is there a possibility to have this zero value in the cholesterol, total cholesterol? Yes or no? Is this possible? Is there any possible? Is it possible?
Practically, no, I think.
Practically no. Okay, so probably this will be a entry error, right? So I will mark this line, right? I will mark this line. Okay, practical. Okay, line. Okay, so okay, so likewise, I will try to find all the errors in the table, right? So maybe I'm not sure the TG might be the 0. Likewise, I am checking everything, right? Everything I'm checking, the 0 ones and some blank one and everything, right? So this is the data cleaning part, right? For so based on my idea, I mean, I'm not a domain expert in the medical field, so based on my idea, I'm just taking the zeros and blank. But you are as a medical side expertise, you can check then the zero. So I'm just taking the 0 and blank, but apart from that, you can maybe check. So whether so generally 2.6 is not a correct value. So you can remove those values as well. Likewise, you can uh, uh, clean up this data sheet to get a good accurate result, right? So that is the second step, right? Data cleaning part. Then the next step is the feature engineering part, right? Feature engineering part. So for this speech engineering part, let me explain this. Okay, wait, right, okay. So, usually, so usually when a patient is come to a near you, you are asking some questions, right? So those questions, based on those questions, you are getting a decision to give the medicines, right? That is the usual process, right? So the questions usually people are the questions you are asking from the patient, we can call those as a X values, call the independent values, right? X1. I will mark this as X1, X2, X3, X3, maybe X4. Those are the independent values, right? These are the independent values, right? And based on this, you will get a decision. We can get this as a dependent variable, right? Why I'm calling this as a dependent? Because of the values of independent variables. So I am going to my decision. For the independent variable, I am marking as a X, then I am marking as a Y for the dependent variable, right? This is for the, that the AI is always, always merged with the mathematics and statistics. Okay. So this is also kind of a mathematics thing, but I'm explaining this is independent, then this is it's a dependent, right? So, okay. So in this case, I'm taking this screenshot. These are the, okay, so, sorry. If I get this, these are the, we usually call the dataset headers as a features of that dataset, right? These are the features, right? Age, gender, then BM, these are the features of the dataset, right? So, if I ask a question from you that, can you tell me what are the independent variable of this dataset and what is the dependent variable of this dataset? Just think about, I am going to predict whether that person is need the diagnosis or not. If that is the use case, what are the independent variable and what is the dependent variable?
Age and gender could be independent.
Independent, okay. Any other opinions? Okay, so in this case, that's also correct, right? And in this data set, I will take age, all of these, right? Age, gender, then BMI, all of these as a what do you call, independent variable, right? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, these 9 features as a independent variables, right? X, right? And I will take this one as a Y because based on these 9 features, I am going to predict whether that person we should that person should go to the diagnosis or not. Based on we will get that decision based on this 9, right? Why I am getting based on my idea. Usually, we are collecting the patient age, gender, BMI, and also let me. So and I'm and the rest of these details we are getting from some reports or blood reports or something. So we usually check the blood report to get the idea of these values, and also we are asking the age, gender, and the other stuff. Then we are combining all these details. Then you are giving the you are predicting the result, right? Or the whether that patient should go with the so based on that idea, I will take all these values as a x values, then this one as a y value, right? Individual. So now that is called as a feature engineering, right? To identify all the independent variables and the dependent variable of the dataset. So that is the step number 3. Okay, so we have completed 1, 2, 3 steps here. 9, 30, okay, 3 steps here. Okay. Now all of these next steps, right? All of these next steps, I am using some of the coding things with some explanation to explain how those things are happening, right? Okay. So in the step 4 is a data processing, right? In the data processing, what I'm going to do is, let's think about, this is my data set, right? This has around how many? 5,133 data, right? This is, okay. So this much of data, this data set has, okay. This much of data, right? Okay, so this is the pen tool. Okay, so this is the total size of data set. Just think about it, right? Okay. So what I'm going to do is, out of this data set is 5,100 data points. Out of this data set, I will take 80% for my model training purposes, right? 80% for my model training purposes, right? So think about 80% might be 4.2 something, right? Around 4.5K data point I am using for my training purpose. That is something like from this to maybe this level, right? That is 80% I am using for to train the model. Rest of 20%, I am using to check my model. Let's say if I created a model using this 80%, I am using this 20% to validate this model accuracy, right? As an example, let's say around 4.2K data, using 4.2K data, I'm training the model. Then rest of the thing, maybe we have around 1K data or 900 data. Then rest of 900 data I am using, rest of 900 data, I'm using this 900 data, I am trying to validate this model to get the accuracy of the model, right? That is my plan, right? So this 80 or 80%, 20% idea, you can change it based on your, maybe based on, okay, you can use 70%, 30%, maybe 60%, 40%, but the recommended way is 80%, 20%. The most of the model training processes, we usually use 80% data to train the model, then rest of the 20% data to train the evaluate the model, right? So in the data pre-processing part is related to this one. So during this data pre-processing part, we are splitting this data set, as I said, to some set of data to train the model, then some set of data to evaluate the model, right? Okay. So here is what I'm going to do, right? Okay. So don't think about any code, or don't think about the things what I written here. Just get an idea what I'm telling, right? Okay. So okay. So I am using Google Colab books to do this model training, because we can use our local PCs as well to do this training process. But it is recommended to use this Google Colab because the Google Colab is providing various type of computers to do our computation things, right? Okay. So first thing, right? I am loading all my libraries to do my model training process, right? And this is my data sheet, this one. I have loaded all this data to the system, right? Once I loaded the system, I am checking the loaded data is appearing properly or not. So that I just try to get the first couple of data to understand whether these the data what I loaded to the system is appearing properly or not, right? You can see that the data is appearing properly. That means the data sheet or the Excel sheet is loaded to system properly, right? Okay, right. Then I am doing a small change in the gender. You can see in here, you can see all these features in these features, all these features are in the numbers, right? Numbers. But in the gender, this is a kind of like I have marked this as a F and M only, right? For this model training purpose, since all of these are in a numbers, I am changing this to the number for the F's. I have replaced with the 0. Then for the M's, I have replaced with the 1. Right? That is what I did in this code, right? Then I defining, or then I'm telling to my system that what are my X variables. As I said previously, these are my X variables. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 X variables here. Then 1 independent variable, right? So I'm telling the system that here is my X variable, age, gender, BMI, cholesterol TG, HDL, LDL. These are my independent variable. Then I'm telling the system that what is my dependent variable? Dependent variable is diagnosis. This one, this column, this is my dependent variable. Okay. So if I go to the first one, I have loaded the data sheet. Then I converted some values to look all those as in a similar way. Then I tell to told to my system that what are the X variables and what are the Y variables, right? Okay. So check the system is properly get my X and Y. You can just check. I will check this X with the X is okay. So these are the X variable, age, gender. Okay. Then I can check the Y. Okay. Okay. So the Y is simple, but okay. You can see here is the Y variable. So X and Y is already taken from the system without any issue. Okay. Now I'm going to this point, right? So I told you I am going to split this data set, 80% of the data set to my training purpose and 20% of the data set for my evaluation purpose. So I am doing that part here, right? I have training X and Y's and evaluation testing X and Y. For the training X and Y and the evaluation X and Y, I have splitted my data set 0.2. 0.2 is a 20%, 20% test data. So for the training, I got the 80%, right? So this is how this is the code where how I split my data set, like to 80% and the 20%, right? Okay. So then I have split it here. Then I am creating my model, right? To create the model, there are a lot of ways we have the model to train the model. We can use there are a lot of technologies, right? So I am not going to explain all those things deeper. In a simple manner, I use the random forest classifier classifier. Don't think about if you are not familiar with that name, just forget about. Just think about I have done the training, right? I have done the training, right? Now I have created the model. Okay, here if you look at, I have created the model, right? Now using this 80% data, I have created my model, right? I have created model. Now what I'm going to do is, using this rest of 20% data, I am trying to get this model's output to check with the actual values, right? As an example, let's say, if in the test side, if I see a patient, let's say patient number 1000, right? If patient 1000 belongs to this test data, what I'm going to do is, I am giving this patient data to the model, then I'm getting the output, right? Whether it is 1 or 0. 1 is need diagnosis, then the 0 is no need diagnosis. I'm giving this to the model. Then after we get this value, I'm going to check with the actual numbers whether this given number is correct or not, right? Because once I get the, let's say, if P01, think about if P1000, the P000, this person, based on the data sheet what I given, this person, if the person need diagnosis, that's mean 1. But if the model predicted as 0, that's mean for this person, the model is not working well. But for the given data, if the model is predicted as a 1, that's mean for this given data, the model is working as desired and as perfectly for the given data, right? So using this model, I will use my X data and predicting all the Y data, right? So once I predicted, right? Data, you can see here, my around 82% of data predicted by model accurately, right? Don't think about the rest of the values. This recall F1, just forget about. If you know about the statistic, you can give a research here, but just see this number only, right? Around 82% of data predicted properly, but another, 18% of data predicted incorrectly in this model, right? So the accuracy of this model is 82%, right? I will show you from one small example here. If you look at this, just forget about this confusion with all the names, right? Just look at this, only these labels, right? Here we have the actual values, right? The person is whether diabetics or no diabetics, right? This is the predicted value, right? So if you look at this column, right, the actual value is the person is suffering from diabetes, but the predicted value is no diabetes, right? If you look at this row, this column, actual value is no diabetes, but the predicted value is diabetes, right? So if you look at these two rows, those are the incorrect values predicted by the model. But if you look at this diagonal, right? If you look at this diagonal, you can see that the actual value is no diabetes, predicted value also the no diabetes. That's correct. Here, this, if you look at this column, the actual value is diabetes, the predicted value also diabetes. So if you look at this table, the good number of data, the model has predicted properly, but there are some cases the model is predicted incorrectly, right? So, okay. So here I'm doing a small check whether my model can use for a scenario, right? Okay. So can someone tell me that these are the numbers I am going to give to the model what I trained now, right? Age is 32, gender is female, BMI is 24, cholesterol level is 146, TG is likewise. Can you just look at this number and tell me, is this person needs diagnosis? In a simple term? Yes or no? My comment is no, right? My comment is no. Okay. So what I'm going to do is, using these numbers, I'm going to run my model, right? So I'm running my model. I gave these numbers to my model. Here I am predicting using these numbers. The prediction result is no diabetic, right? So for this scenario, the model is predicting properly. I am just trying to change some values, right? Let's say maybe I'm changing this cholesterol level, maybe 246. I'm not sure whether this number is correct. Let's try. Still no diabetics. So likewise, I can change this and check whether the result is coming at the level what I need or not, right? So if you think that the model is not performing well, the only way the thing is that to feeding the correct data, right? Feeding the correct data. So or the model result is always depend on the data what you are inserting or what you are using to train the model, right? Okay. So okay. So so I believe I explained all these 8 steps now. How from data analysis part to the development stage. So you also, if you have some data, you also can give a try to train a kind of a model. If you don't have an idea about the Python code or some using some technical frameworks, you can just ask from ChatGPT. ChatGPT will give the code, then you can give a trial, right? Okay. So, and one more last thing I wanted to show you, because I am showing this because in the last session I go to the recorded video last session. There are some questions about like accuracy, right? So that's why I decided to show this training process and this confusion matrix, right? For the most cases, AI might generate some wrong thing, right? So in this case, if you look at these two columns, the AI generated the wrong things, right? What we can do is we can reduce this to 0, but that's depend on the data set or the tokens what we are giving, right? So I will show you now, right? I will show you one thing. Okay, so this one, right? So for the model training purpose, we use some data set, right? In this case, this is the data set what we use, right? If you look at, this has around, if you look at all, usually we tell a small portion as a one token, right? We have a very broader definition, but just think about the one column as a one token, right? If we get that manner, I used around 51K tokens to train my model, right? That is the number of token I use to train my model, right? But if you go to this is how I try to explain. So let's say example, if I if I use I love pizza as an input to train my model, this has around 4 token, 1, 2, 3, and 4 token with this, right? There are 4 tokens, right? So if you look at this table, this is the number of tokens what the GPT used to train their models, right? Example, GPT-1, they started in 2030. They used around 117 million tokens, right? Then when they introduced GPT-2, they used 8 billions of tokens, right? 8 billions of tokens. In the GPT-3, when they introduced in 2020, they used 300 billions of tokens, right? 300 billions of tokens. So they have not given the number of tokens for they used for 3.5, 4, and 4 turbo. 4 turbo is the most accurate, and that is the one they are giving when we get the paid version. So if you go to these tokens, right? Tokens, let's say this 117 million token is used for the general domains. General domains means covering all the domains, right? But if you look at this table, you can see that the estimately the GPT-3 used around 10 to 15 billion token out of these maybe 117 million, 8 billion tokens, right? They used in ChatGPT-3. Then ChatGPT, they have used 300 billion tokens. They have used out of the 300 billion, they have used around 10 to 15 billion tokens from the medical field to train the model, right? Then now you should be able to understand that out of 300 billion token, they used only 10 to 15 billions of tokens to train their model, right? 10, if you get as a 10, what is the percentage? Maybe around 2%, 3%, 5%. Yeah, around 5%, right? If I am not wrong, yeah, that is 5%. So now you should able to understand that even though the GPT used the 300 billion tokens, from the medical field, they use only 10 billions of tokens. So other 280 billions of tokens they use from the various other domains, right? So that's what I wanted to tell you, because I saw that there are some questions about the accuracy. So accuracy is always depend on the number of tokens they have used and number of the accuracy of the tokens, right? So that is very, very difficult to tell to us that which model is accurate, but that is depend on that is always changing, and that's depend on the way they are training and the data set they are using, right? And also I have put some slides how the Google DeepMind use the token when compared to the GPT. The Google MeanMind is using the bill the n number of millions token when compared to the GPT, because the Google has a lot of data servers. So when compared to the GPT, so this is how the GPT use the token to train their models, right? Yeah, that's all for today. So before we end the session today, do you have any comments about the what we have explained today? And do you need put any comments or change our way we are doing the lecture, or do you want to add any comments? So we really appreciate it.
I think you clearly explained this how we train the model because I also can't understand even how this is done. But now it is clear. In simple terms, you explained it. I think it's very good.
Yeah. Thanks, Devinder. So good. So I believe that the rest of the team also able to understand. But if anything unclear, let's we can discuss in the next session as well. If needed anything unclear, you can ask any question from me or from Maisha as well. So we are happy to discuss anything. If needed. Now the picture becomes clear. Thanks. Okay, wonderful. Yeah, you will try every time to clear with some pictures and some graphs. So that's the better way to give some good input and good to get engaged with the audience. So then, thanks everyone. Have a nice
Thank you.
weekend to everyone. Let's meet
Thank you. Thank you.
next Saturday. Thank you. Thanks, Maisha.
Thank you.
Thanks
Good night.
everyone.
Thank you.
Thank you.
Good night.
Thank you very much. Thanks.
Thank you. Good night.